Hello, everyone, and welcome back. Today, I am chatting with Rob Slaughter, the co-founder and CEO of Defense Unicorns. Rob previously served in the U.S. Air Force, and now he's building software infrastructure for defense and national security customers. Defense Unicorn focuses on mission-critical software, secure deployment, and DevSecOps practices inside the actual Department of Defense. And today, Rob, I'm so excited to have you on and actually talk about why defense software is still so hard, what the Pentagon needs from modern software companies, and how AI is completely changing the national security technology stack. Rob, welcome, and thank you for joining us.
Yeah, absolutely. Thanks for having me on the show.
Amazing. Maybe we can start off just setting the scene for the audience. What does Defense Unicorns actually build for the Department of Defense?
Yeah, it's all about getting software to warfighters, which might sound like it's straightforward, but in military systems, it's incredibly complicated.
Mm.
What makes it complicated is really a series of things. First, these are highly secure, many times air-gapped environments. Many times you're running on somebody else's infrastructure, serving potentially somebody else's platform, running somebody else's mission app. And really, the third thing that makes this very complex is, this isn't centralized compute. This is all about decentralized, highly distributable systems, really deployed across the world, and really being managed by like really everyday Americans. They're, the infrastructure, platform, and software isn't getting managed by, some Google SRE. It's getting managed by some soldier or Marine or airman. And so you have to really abstract a lot of the things that makes it difficult and make it easy for those folks to manage their own software.
Yeah, no, definitely. And something that you even said is that software is the country's newest weapon. What does that mean? Why is that the case?
Yeah, so to me, it really goes back to, if you think about what's going on with society right now, I think there's a ton of parallels
Mhm.
between, advancements in AI and the nuclear bomb. You have really these nation states really start to have this quiet ramp up of what's really, at the end of the day, kind of an arms race. There's been a lot of recent policy that was just
Mhm.
released on starting to restrict access to things like Mythos and other open AI models as well now. And so really what we mean by that is whoever's going to win the next war, whoever's going to win the next engagement will be the country or military who is best at software. And so all new modern systems are software defined systems. And so you really have to start thinking about software as a weapon system itself.
Wow. So AI, you just compared AI to a nuclear bomb and saying those who control AI and control software ultimately have a lot of power and a lot of responsibility. And so I'm curious, how does Defense Unicorns come into that conversation? Where is AI actually doing the real work in defense today?
Yeah, so that's a great question. As of today, at least, U.S. still leads, and when it comes to frontier models and AI capabilities, obviously China is very close behind. I think really, really, really close if you look at some of their latest open source models. But for the U.S. military, it's all about actually deploying it to the systems that need it. Because AI not in the hands of the actual operators or AI not next to the actual mission data isn't very useful at all. So,
Mhm.
said another way, AI operating at an unclassified system doesn't actually provide us a warfighting capability. What provides us a warfighting capability is AI running on a secure and classified system. Current military operations that might be, is possible for certain systems, in like secure cloud deployments. But really where the gap is and where Defense Unicorns plays is in these highly distributable, highly decentralized system. Really when you start looking about edge compute. And so we run as a company and have developed a system called UDS.
Mhm.
It's a unified defense stack. It's deployed across 85 systems today. It supports over 457 new capabilities. And the majority of those capabilities, more and more often now are running AI workloads.
And something unique about your guys' work is that all of the code is open source. And it's almost in juxtaposition to what a lot of people would say. It's like, oh no, close source everything so that adversaries can't see that. But you actually insist that open source is how you make things more defensive. And walk me through that. Why does it feel like these juxtapositions?
So it really just comes back to collaboration.
Mm.
It's our goal to have UDS on all 100% of US assets. The way you have to do that is an open source approach. And I'll actually use Chinese AI models as an example.
Yeah.
China may completely dominate AI one day when it comes to an open source model. I can almost guarantee you that the Department of War is not going to use that model in operations, or not use it regularly in operations. Why? It's a Chinese model. To us, UDS is the same way. Like our are not going to be interested in using our technology in military operations, but all of our allies might. And so, how do we support those allies? How do we make sure that they are able to actually manage their system in a non-vendor locked way, while as a vendor still providing best in class capability? And the only way to do that is an open core model.
Wow, interesting. And so, what I'm hearing is if you think people who are adversaries are going to take your open source and that use that for bad things against you, that's actually not what you're seeing in practice. And so, what would you say is maybe the main thing people get wrong when it comes to open source?
I think the number one argument against open source is security. They see the fact that it is open to the public as an actual vulnerability. The reality is the majority of the world today runs on open source software.
Mhm.
The vast majority of closed source software is actually open source under the hood, with a small amount, a small percentage of the code base actually being their proprietary so what. And so, there's a lot of arguments that people make around, hey, are you concerned if UDS is flying on all these weapon systems and it's open source that this is somehow a vulnerability?
Mhm.
Are we concerned of that? Absolutely, we're concerned, and we should be. But the reality is there's already dozens of software products that have that level of distribution. Things like Kubernetes, things like Linux, and a variety of products in the Linux Foundation, as well as the Cloud Native Computing
Mhm.
Foundation, CNCF. Those products have mass distribution across the Department of War today, and a lot of them are being maintained, not just by U.S. and allies, but actually by foreign individuals as well, and some, in many of in cases, not actually, people who are our friends.
Yeah, that's super interesting as well because you talked about security, and right now you guys have to work on a lot of speed. You guys have to do things very fast, and the future that AI and everything is going towards, it's like imperative that you're building in super fast ways. But your guys' customer is the U.S. military, and so values like security is probably the most important thing to do. So how do you deal with that trade-off between speed and security at your guys' company?
Yeah, you really nailed it. You can't compromise security for speed. You really have to bake in security into the actual software development process itself. And so, really, in today's society, this is all about agentic AI workloads
Mhm.
and AI loops. And you just have to effectively take the extra cycles to build in the security into those loops themselves. You can't just, vibe code with no guardrails. You have to actually bake in the scaffolding and the guardrails themselves and the entire software development lifecycle.
What does that actually look like though for you guys?
Yeah, so it's simple things like just looking at vulnerabilities, CVE counts. It's actually testing it. It's actually AI automation when it comes to like pen testing, the
Mm.
capabilities to see what's exploitable or not. If something is exploitable, how do you then reprocess it? And the other big thing is how do you take functions from a security perspective that don't need to be regenerated from an AI perspective
Mhm.
every time? How do you actually take the functions from a security perspective and make them fully declarative? And so what I mean by that is like you don't need to reprogram how you do your IDAM or SSO, meaning like how does a user authenticate and log into a system? You don't have to actually regenerate that every new application. You can actually sit that in stone, make it declarative, make that robust, and then when you're building capabilities on top, that's really where the AI workloads, take advantage. So it's really a combination of when do you use AI for when it's best of the world at,
Yeah.
and when do you not use AI because you already have something that works today.
Interesting. And what I find also very fascinating is that even though your customer is the US military, probably everyone could benefit from having AI that's more open and more secure and more decentralized. Is that what you're also finding too?
Absolutely. I think being an open source company, we're always fascinated by the people who are using our open source technology. So one of our open source technologies, Zarf, it's used across the world today in air-gapped environments. Every time you go through a TSA checkpoint, they're running on Zarf. Things
Wow.
like oil rigs, different energy partners. And so, I think a lot of the things that we're solving for the U.S. military, that's our customer, that's our focus. As a company, it's really important to us that we stay focused there. But a lot of the technology that we're developing off to the side is actually finding use cases really across the world.
Definitely. And It's also interesting because a lot of people who are maybe working on defense startups or AI in defense don't have that same Air Force background that you do. And you particularly came from the Air Force world, not just the Silicon Valley tech world. And so I'm super curious, how does your personal experience influence what you actually ended up building with Defense Unicorns?
Yeah, customer intimacy is, I think, important no matter what, really domain you're in. We lived the problems. We felt like as individuals that nobody understood the problem better than us. And honestly, we tried to solve those problems while still active duty. And so, we really came to the realization that it really is going to take a company whose sole focus is to really rebuild the military tech stack from the ground up and to just 100% focused on the talent necessary to do that. And so I think it gives us an edge. We know what works, we know what doesn't work. We obviously understand the acquisition process as well, which is many times a moat. We understand, how difficult it is to run a company. There's a lot of companies out there that rely on a ton of international and foreign developers in the U.S. military. That's something that they really hard. It's very important that this is, U.S. development as a primary focus. And we really felt like as individuals that we could actually come to the table and build this new technology.
That's amazing. That's amazing to see. And you're specifically working on AI in the defense world. And I think this is something that instantly a lot of people feel very passionate towards, but also may not totally understand what actually happens under the hood and how adversaries might use artificial intelligence and use this technology. And so I'm curious if you have a specific insight and understanding about defense and AI that maybe the public doesn't totally know quite yet.
Yeah, I think that's a great stage setting to really the problem we're trying to solve.
Mhm.
And so to tie it back into my background in the military, approximately 10 years ago, I was deployed in the Middle East. I was deployed with like 4,000 airmen, and we were managing about 70 aircraft. Think of it as 70 systems of war. With modern warfare, what's really changed is the number of systems and how much those systems need new software and new capabilities. So one can imagine, our next, wide scale engagement, that's not going to be 4,000 people managing 70 systems of war. That's probably going to be 70 people managing 4,000 or even 40,000 systems of war. And so
Mhm.
your ability to actually, supply new capabilities, new software features, everybody following the news today, it's like every day, every week, there's a new drop. How fast as a nation can you actually get that new drop of capability actually fielded into those systems? And oh, by the way, it's several orders of magnitude more systems. And so all of these problems that we see today on like the F-22 or these major jets or submarines, they're about to be compounded because we're about to go from these few systems of war to several orders of magnitude more at the same time that the importance of getting that new software update has never been more foundationally important.
And I'm curious how you deal with the two parallels of saying if we're not keeping up, if we're moving too slow, we're going to lose to our rivals who are doing the latest things in AI and being the fastest in the room. How do you deal with that? How do you hold both at once? How do we not rush technology in a way that we're not able to take back later on?
Well, first, I would say that you always have to, in software updates, you always have the ability to actually, produce the next update, which might actually be a fix. But if that fix takes months to years, you're at a superior disadvantage. And I think that's the overall point. Obviously, with software testing, you want to make sure these things are as good to go as they possibly can be. But the reality is things still break.
Mhm.
The military also has issues. Things break in operations. Really, it's a question of how fast do you want to fix that? If you're having an issue with the weapon system, how fast do you want to fix that? The reality is today, that's literally months to years. And during that time, that system might be out of the fight. You just held back the entire capability drop, which is what most systems do today. If you actually have the ability to update software on demand, it doesn't mean that you're never going to have issues. But what it means is that when you have an issue, you're going to be able to fix it really quickly.
And my last question for you is in a world where defense unicorns is radically successful, what does that world actually look like? What changes day to day?
I think our vision for the country is that we have the ability to update software on demand on 100% of all U.S. military assets. We think that will be the capability we need as a nation to win the next war before it starts. From a mission perspective, we describe it as, make software a strategic deterrent. Be at such a superior advantage to our adversaries from a software perspective that they never even entertain the idea of going to war with us.
Wow, that's amazing. And that's really incredible and incredibly important to what's happening right now in the world today. I know we're at time, Rob, but I wanted to thank you for coming on and telling us a little bit more about defense unicorns and a lot more about the important work you guys are doing when it comes to defense and AI's role in defense. So, Rob, thank you so much for joining us.